Hello everyone. Today we are going to discuss about open close principle. Principle states that a class should be open for extension and closed for modification. That means open for extension. You should be able to add new features or functionalities to your code without changing the existing code. Closed for modification says that once a code is written, it should not need to modify to accommodate new behavior. That means you should be able to write a code that is open for extension, that is to add any additional features, but closed for modification. You should be able to open it for extension and close it for modification. This reduces the risk of introducing new bugs into tested and working code. That means once you written the code, you should not be able to modify it which is already tested and working well. You should add additional features using the extension points. We will be discussing this in detail with an example. So you should be able to extend a class's behavior without modifying it. Open for extension. Open for extension we can do on three extension points, which is abstract classes, interfaces, as well as virtual methods. We close a class for modification using private and sealed classes in C hash. Whatever the examples we consider, that will be explained in C hash. Considering a requirement called pay, which is happening to self as well as others. And if I need, I can add this to bank also. So the abstract class extension point, looks like this. See, here we have an abstract class called a PhonePe. Abstract classes are represented or starting letter of the class name will be with A. If it is an interface, it will be with I. Since we are using abstract classes, we will be using A, which is represented in here like this. It has a method called pay. That means whatever the class that extends this abstract class must implement this pay method inside it. So here we have two requirements, which is paying to self, which is paying to others. Now in self I have a pay, and as well as in others I have pay method. Here I have closed this class for modification. This is already implemented. That means I have to close it for modification. C stands for closing for modification, right? Similarly, I have used a private keyword in here to close it for modification in C hash. Here we have used seal. Any one of this can be used to close for modification. And I have opened this feature for accommodating new features into the same thing. I have opened this extension point. This is the extension point that helps us to extend it for other accommodations of new features. So this is how abstract classes are used for extension to add new behaviors and closed for modification using private or sealed, whatever the keyword. Now let's see an example in C hash C# language. So the abstract class we have in here, that is a PhonePe, which has an abstract method pay. Now this abstract PhonePe class will act as an extension point. Here we have the sealed classes which are closed for modification. Now I have sealed class, that is PhonePe self, and the other sealed class which is PhonePe other. These classes are getting extended by an abstract class. Since these are getting extended, we have to override the methods, that is abstract method inside this. So when we override the abstract method, it looks like this. Now here I have closed it for modification by using sealed, and I have an open extension point from the PhonePe abstract class. Now if I want to add another class that is paying to bank, so I can extend it but not modify the above classes. Since we have the bank class that is getting extended by PhonePe, we have to implement the method which is inside it by overriding. Now in the main program, we have a PhonePe type of object. The object is paying to self in here. Now the object is paying to others. Whatever the object, the relevant method inside it will be called. Whatever the object is created, the object's method is called from here. So when I execute this is how the output looks. Since we didn't create the bank's object and call the pay method, we couldn't see it in here. So this is about extension with abstract classes and closing with C keyword. We can also use private keyword instead of sealed in here. Now, interfaces. Interfaces, as I mentioned before, interfaces name starts with I and respect followed by the class name, I mean interface name. So here we have a pay method in the inside interface. If it is this interface is extended by any of the class, then it must implement the pay method as it mentioned in here. Now here we close it for modification by using a keyword called sealed or private, whatever it could be. Once we have done with that, we should be able to open this for extension. That means I have an extension point from the interface where I can add new functionality or new feature like paying to the bank. Whatever the class, I can draw it in here and implement it accordingly. So this is how we implement using interfaces. Now let's see the same with interfaces. Interface PhonePe, which has a method pay inside it. When this is being implemented by the subclasses, it must implement the method inside it. Now here I have PhonePe self class which is sealed to make sure that it is closed for modification being extended by an interface, being implemented by an interface. When this is implemented, the method inside it must be implemented. So this is similar to the PhonePe other class. Now, when I have the main function with the two objects that we have created in the here for the classes in that is self and the other, now I'm calling the methods with the created objects. When I run the program, it prints the output which is being in here. If I want to add additional feature, I can add another seal class that is getting implemented by interface and a method that is used inside that class, and I can extend the functionality of payments. So this is about interface extension point and closing it with sealed or private classes. Now the third extension point which we have is virtual method. Virtual method, virtual is a keyword that is used before in the method that is used, I mean at the header of the method, virtual void pay, like that. So this virtual keyword can be used so that you can override it in the subclass. To override the methods, we have to use virtual in C hash. So for which we have implemented OCP, that is open close principle, using virtual methods. This can happen like this. Abstract class, you can take abstract as well as, yeah, you can take abstract class. Now I have a phone pay. A phone pay. A represents it's an abstract class which has a method called pay. Now here this self is getting extended by self is extending a phone pay. Now it must implement pay. This is a virtual method and this is a method that is overridden. This method is overridden in the subclass which should must happen, and this class should be sealed so that you can close it for modification. And here we have an extension point to open it for extension. So this is about open close principle. Looking at the third example, using virtual methods, we have to use the virtual keyword before the return type of the method. Now, this virtual keyword represents that we can override the method in the base class. Since the self is being extended by a phone is being extending a phone pay, we can override the method inside it. That means it must be implemented and can be overridden inside it. So this is how I have overridden. Here we have paying and here we have updated it to payment using PhonePay self. Now I have created an object of PhonePay self and call the method inside it. When I execute the program, it will be calling the overridden method that is payment using PhonePay self. So this is about virtual method extension point, and you can make sure it is closed for modification by using the sealed in the concrete class or the base class.